Hey, it's Mr. Jensen. Today I'd like to go over some general ideas of relative humidity and dew point temperatures. So the first picture I have here is this kid. It looks like he's really hot. It looks like he's been doing some activity, so he's really sweaty. And that's probably due to the day that he's experiencing in this photo. So it looks like they're out at a baseball field on like a warm day. Now, we've all experienced warm days where you get really warm from being outside, but it looks like this is even extra from just being warm. It's probably really humid. And we've all experienced like a humid day, probably at the end of July, middle of July, or like August. So humidity is the amount of water vapor that is in the air. And it makes you feel like it's much warmer out than it actually is. They say, oh, today's temperatures are 80 degrees Fahrenheit, but it's going to feel like 100. That's due to the amount of water vapor that is stuck in the air, making it feel hotter. So I have another photo to compare that to. This is like a really nice, clear day. It would probably be very, very dry outside, meaning that there's no water vapor in the air to make it feel warmer than it actually is. So this would be a day that has a low relative humidity and is very dry. It's probably nicer to be out on a day like this than it was on the previous photo because it would just be easier to breathe. You would be able to stay out longer without being too hot, et cetera, et cetera. All right, so let's talk about the differences of these two photos and what water vapor in the air does for relative humidity. So here I have 1, 2, 3, 4. I have 4 what we would call parcels of air, just means an area of air, and they're 1 unit of air each. But you'll notice that they're each different sizes. So I have over here my biggest one at 85 degrees Fahrenheit, and over here I have my smallest at 30 degrees Fahrenheit, which if you could figure out the relationship, the warmer the air, the larger it is. So as I go from 85 degrees down to 30 degrees Fahrenheit, my parcel of air shrinks. So if we wanted to summarize that, we could say that warmer air is larger. Warmer air is larger. So if it's larger, it actually has more space for water vapor to fit in. So on an 85 degree Fahrenheit day, when we have an even amount of water in all of these parcels of air, on an 85 degree day, only a little tiny bit of water vapor is in there, and so we would call this day low humidity. This is the lowest humidity out of all 4 pictures because there's so much more room for water that the air has, and it's not filled up. So it's a really low amount of water vapor in that air. So 85 degrees Fahrenheit is the largest, has the most room for water vapor. It could fit so much more, so this is the lowest humidity. As the air shrinks, it's the same size of water. As the air shrinks, it starts to take up more and more and more space inside of that air until we get to 30 degrees Fahrenheit, which is totally 100% filled with water vapor. So this relative humidity would be at 100%. It's at a total 100%. It's completely filled with water vapor. And this would be a high humidity. So if this was one single day, right? Although this usually doesn't happen, this is a extreme case. If this is one day, we have a beginning temperature of 85 degrees Fahrenheit. It's very low humidity. It's a very dry day. As it gets colder and colder and colder, the relative humidity goes up and up and up. And at 30 degrees Fahrenheit, it's totally and completely filled with water because it shrunk so much. There's absolutely no space for any more water vapor. When it gets to 30 degrees Fahrenheit and it is at 100% relative humidity, we call this the dew point. And the dew point is the temperature of a day. It changes daily. Dew point is the temperature of a day that will cause water vapor to go from a gas in the air to back to a liquid that has to latch onto something. And most of the time we see this in the morning or in the evening, we see it as dew. So you'll see all these little droplets of water all over these pieces of grass, right? And that's dew. So it's when a high relative humidity day, and when the temperature goes down to a certain point, it has to squeeze the water out of the atmosphere, kind of like a sponge, and it creates dew. So one more example of this. So this last slide is going to be an example of how relative humidity and dew point work together. So this first block on the left we'll say is 2 p.m. Right? 2 p.m. is usually the warmest part of the day. We'll say it's part of the summer. So it's 2 p.m. in the summer. So maybe my temperature of that day is 90 degrees Fahrenheit at 2 p.m. And so you'll see that this isn't fully filled with water. So we'll say that this is 75% relative humidity. It's pretty filled up, but not all the way, and a little bit more than half. So 75% relative humidity at 2 p.m., and it's 90 degrees Fahrenheit in the summer. As the day goes on, the sun is going to go down, and it's going to get cooler and cooler and cooler. And so maybe by, let's say, 6 p.m., the day has cooled off 20 degrees, and now it's only 70 degrees Fahrenheit, which causes the air to actually shrink, but the water vapor didn't go away. So now that there is the same amount of water vapor, but the air is smaller, I'm going to go back to 100% relative humidity because my air shrunk. And when the air reaches 100% relative humidity, we call whatever that temperature is for the day our dew point. So in this particular example, 70 degrees Fahrenheit was our dew point. And it could either start raining or it could condense the air back into water droplets from being a gas. All right, so that's an overview of relative humidity and dew point. Thanks for watching. All right, so just one last thing. Here is a actual forecast of today. From weatherstreet.com. I just Googled it. So here is an actual forecast from today. I'd like to show you guys on like a real weather forecast. Right now, it's 45 degrees Fahrenheit. Probably because of the wind, it feels like 44. The actual temperature of the air is 45. And so you guys will see here, it says the relative humidity is 41%. Although I feel like I just blocked it. So 41%. So that means that there is plenty of more room for water vapor to fill into the air. But today, if the temperature shrinks down or decreases to 23 degrees Fahrenheit, my relative humidity will be 100%, and there will be a very high chance of rain, and definitely a chance of dew being on the grass